Welcome to The Explainer. Today we are unpacking one of the most fascinating and, let's be honest, sometimes mysterious pieces of tech that runs quietly in the background of our digital lives. We're talking about the massive system architecture behind those people you may know algorithms. If you are on Meta, LinkedIn, X, you name it, you have interacted with this exact system. It's the engine recommending new relevant connections to you. And the engineering required to pull this off at a global scale, it is absolutely mind-blowing.
Right, so let's start with a feeling I know we've all had. You meet somebody new, maybe at a coffee shop or a work conference, you chat for maybe 10 minutes, and then later that day, boom, there they are, showing up as a recommended friend on your feed. It kind of feels a little bit creepy, right? You probably even joke that your phone's mic is listening in on your conversations. But here is the wild truth. It's not your microphone. It's actually the astonishing power of graph structure and predictive algorithms literally connecting the digital dots of your life.
And to really appreciate this, you have to think about the sheer scale of the problem. We're not talking about searching some tiny local database here. These platforms are sorting through a massive social graph of roughly 2 billion nodes. That's 2 billion users and hundreds of billions of connecting edges between them. So finding that one perfect friend suggestion for you, it's like finding a tiny needle in a 2 billion node haystack that's constantly shifting and changing, and they have to do it all in a fraction of a second.
So how do they actually pull this off? Well, here's our roadmap for the explainer today. First, we'll look at the ultimate matchmaking problem. Number 2, we'll see how they tame the social graph. 3, we'll dive into scoring and ranking connections. 4, the machine learning under the hood. And finally, number 5, the strict privacy and guardrails. Let's jump right in.
Section 1. The ultimate matchmaking problem, finding meaningful ties.
The goal of a system like People You May Know isn't just to find anyone that you might recognize. It's about finding the right people. The engineers building these things understand a really critical distinction. Predicting whether two people already know each other is entirely different from predicting whether a suggestion will actually be accepted and valued. Think about it. If the algorithm only cares about structural links, like, hey, you have 40 mutual friends with this person, it's just going to oversuggest obvious people you clearly already know, but have actively chosen not to add. And worse, it totally misses out on those valuable weak ties that could actually expand your professional or social circle. So what's the actual true objective of the machine learning model here? It's pretty simple. Maximize the probability of an invite being accepted and multiply that by the long-term connection value. The platform wants to grow a meaningful network for you because that drives long-term engagement. What they definitely don't want to do is blast you with spammy or unwanted suggestions that just make you hit the hide or report buttons.
Section 2. Taming the social graph, billion-node computing. Okay, so we know what the system wants to do, but practically speaking, how on earth do you search across billions of accounts without literally crashing the servers? Well, the answer is a brilliant two-part system. You have offline heavy lifting and online serving. Because the graph is so impossibly huge, you just can't compute all those friend-of-a-friend connections in real time the second you open the app. It's way too slow. Instead, they run these massive, slow, distributed graph jobs in the background, totally offline. That creates a pre-computed pool of candidates. Then, the lightning-fast online service just pulls from that ready-to-go pool the exact moment you refresh your feed.
Let's break down that offline sifting process, because this is all about pure brute force. The friend-of-a-friend space explodes exponentially. Just for you, one single user, the system might initially generate anywhere from 10,000 to a staggering 1 million potential candidates. Obviously, that's way too many. So the system aggressively prunes that massive list down to a manageable few thousand using hard thresholds, like requiring a minimum number of mutual friends. These finalized, pruned candidate pools are then cached daily, sometimes even hourly, and they just sit there, waiting for you to open the app. Section 3. Scoring and ranking connections, deciding top spots.
All right, so the offline servers have narrowed down your personal universe to a few thousand candidates. But how does the AI decide who gets that coveted top spot right on your screen? It all comes down to feature engineering. The AI looks at a diverse mix of signals. First, graph structural features. This is stuff like your mutual friends or advanced math like the Atomic Hadar Index, which basically measures how tightly knit your mutuals are. Then, profile matches. Did you go to the same school, work at the same company, live in the same city? It also heavily weighs interactions. Have you viewed their profile recently? Because that shows clear intent. And finally, user-level features. Look at your own historical behavior. Are you someone who clicks accept on everything, or do you ignore most invites? Every single candidate gets scored across all these distinct features.
Section 4. Machine learning under the hood, the brains of the operation.
We've got our features, right? But what kind of brain is actually crunching these numbers to generate that final score? In the world of massive social graphs, engineers are constantly debating between two major modeling approaches: gradient-boosted decision trees, or GBD, and graph neural networks, or GNN. And there's actually a really fantastic lesson in system design here. The absolute fanciest, most cutting-edge AI isn't always the best fit for production at scale.
There are some major trade-offs at play. On the one hand, graph neural networks are incredibly powerful. They capture all these deep structural nuances and are especially great at helping brand new users find connections. But they are staggeringly expensive to train and serve on a billion-node graph, and they are notoriously difficult to debug. On the other hand, a GPT model running on handcrafted features, it's cheap, it's highly interpretable, and its performance is still incredibly strong. And that is exactly why many production systems actually stick with a GPT-first approach. There's also another huge issue they have to counter: homophily, or the echo chamber effect. If an algorithm relies purely on who your friends know, you just get trapped in your existing little bubble. To fix this, modern systems mix in profile affiliations and inject a little bit of light exploration to broaden your network reach. They intentionally surface those weak ties from outside your immediate cluster.
Section 5. Strict privacy and guardrails, protecting user data. Now, social graphs contain highly sensitive real-world relationships. One wrong suggestion could have massive privacy implications. To manage this risk, suggestions run through what's called an online gauntlet. All 5 of these steps happen in under 100 milliseconds the moment you open the app. The system loads your pre-computed pool, fetches any fresh features, ranks them with the ML model, and then hits step 4, applying the privacy and abuse filters before finally serving your top suggestions. And let me tell you, step 4 is absolute law.
Let's look at those safety shields a bit closer. The system must strictly honor blocks and privacy settings, but most importantly, it can never ever reveal hidden edges. For example, if it tells you that you have 3 mutual friends with someone, it cannot include a mutual friend who has set their friend list to private. If it did, that's a privacy leakage incident, and the acceptable metric for those is exactly 0, no exceptions. The algorithm also has to safely navigate cold starts for brand new users, and it does this by relying strictly on imported contacts the user has explicitly consented to share. Plus, it's constantly monitoring for abuse, shutting down scrapers and rate-limiting bots that try to mass add thousands of accounts to build spam networks.
So we've seen how incredible the engineering is here, right? Offline sifting through billions of nodes, complex machine learning ranking features in mere milliseconds, and stringent privacy shields ensuring our data stays totally secure. But it kind of leaves us with a provocative thought. If these algorithms are explicitly designed to maximize the probability of acceptance, and they carefully curate our meaningful connections using all this deep math, are we building our networks, or are the networks building us? Thank you so much for joining me for this explainer, and keep questioning the systems that shape our digital world.